our school years, we have heard the terms rocks and minerals plenty of times, but most of the time we only know what they are instead of how they came to be. Thus, in just under 15 minutes, I, along with Kyle, Maria Teresa, and Ramil, will discuss the basics to ensure that you will understand all there is to know about rocks and minerals. Now, let's dive into it. The first topic that we'll be tackling is minerals. So before we get into anything else, we must first establish its definition. So, what are minerals? In layman's terms, minerals are basically naturally occurring substances with an internal crystal form that build up the Earth's crust. And they are also what you call the building blocks of rocks, as rocks are composed of them. To truly understand what minerals are, we must be aware of the 5 characteristics or criteria that makes a mineral a mineral. First, as I've mentioned, minerals are naturally occurring substances, so this means that they must not be man-made. For example, paper and plastic are man-made, thus they aren't minerals. Second, they are inorganic, and this means they must neither be living nor made from living things. Third, they are crystalline solids. I shall emphasize again that they must be solid under natural conditions. That said, liquids like water or gases like air are not minerals. Fourth, they have a definite chemical composition. Each mineral has a particular mix of elements that are unique to them. For example, fluoride is composed of calcium and fluorine, while pyrite is composed of iron and sulfur. No other mineral shares the same composition as the two. And fifth, the atoms that make up these substances must be arranged in a particular order or structure. This is what causes the mineral's crystal structure and other physical properties like hardness and color. For one, quartz transparency is because of the specific order of atoms. Additionally, they are made up of bonded atoms in particular. Remember how I mentioned that they were made up of atoms? Well, ions are basically those atoms which are charged. Going back to the basics, there are positively charged ions or cations and negatively charged ions or anions. Like in our previous example, fluoride is made up of calcium, which is a cation, and fluorine, which is an anion. Now we know what a mineral is and its criteria, let's briefly discuss the different classifications. These classifications are based on 2 factors: their physical properties and their chemical composition. The first classification are silicate minerals. So these are considered the most common type of minerals as they make up the majority of the Earth's mantle and crust. And the essential component of these minerals is the building block that we call the silicate tetrahedron. So what is it? It is basically a specific structure of atoms, and as you can see, it consists of 4 oxygen atoms closely arranged around 1 central silicon atom. Now there are 2 subcategories of silicate minerals. There are mafic and felsic silicates. Starting off with mafic silicates, these are minerals that are rich in magnesium and iron. The presence of these elements is what causes the common characteristic of them being dark in color. Some examples are common rock-forming ferromagnesian minerals such as olivine, pyroxene, and amphibole. Moving on, felsic silicates in comparison to mafic silicates contain lighter elements. These include potassium, sodium, and aluminum. And again, contrasting to mafic silicates, these are light in color. Some examples include quartz, muscovite, orthoclase, and feldspars. The next classification are non-silicate minerals. So these minerals don't contain the silicon-oxygen combination that silicates have. They may still contain oxygen, but not silicon. Now, let's quickly discuss the 6 subcategories of non-silicate minerals. First are oxides, which contain cations bonded with oxygen. Some examples are corundum with aluminum and oxygen, and hematite and magnetite with iron and oxygen. Second are sulfides, which are composed of cations plus sulfur. These include pyrite or fool's gold with iron and sulfur, and sphalerite with zinc and sulfur. Third are carbonates, which contain cations plus the carbonate anion. Known examples of these are calcite and dolomite. Fourth are halides, which contain cations bonded to chlorine or fluorine. Examples are halide, and our constant example, fluorite. And the last 2 subcategories are sulfates, which contain cations bonded to the sulfate group, and phosphates, which contain cations bonded to the phosphate group. Moving on to the next classification, we have metallic minerals. These are minerals that are composed of one or more heavy metallic minerals like chromium, iron, and nickel. Some examples include magnetite, hematite, and goethite. The next classification is basically the opposite of the previous one, which are non-metallic minerals. These do not contain metallic elements and thus do not hold metallic properties like electricity, metallic luster, and good heat conduction. A few examples are sand, marble, gravel, clay, and limestone. And lastly, we have gem minerals. So these are simply minerals that are commonly used for jewelry or other ornamental applications. They are usually very colorful and attractive, and rubies, diamonds, beryl, and jade are only some of the many gem minerals that exist.
There are different factors that are considered in order to identify a mineral. For today, we are going to discuss the 5 most common factors. The first one is habit. It simply refers to the overall shape or growth pattern of the mineral. It is concerned with the mineral's general appearance, like whether it is blocky, long, and so on. There are many different types of habit, but these are just a few. First is equant. This is when the length, width, and breadth are roughly equal, like a cube or sphere. The next is platy. These minerals are usually flat and tablet-shaped, like the wolfenite we see on the screen. We also have a circular. A mineral typically has this when you see that it has a lot of needle-like features. As you can see, there are many other types of habit apart from the three. Additionally, it is also important to know that while some minerals have distinct habits, most have differing ones. The second factor is luster. In simple terms, it is basically how the surface of a mineral reflects light. In terms of quantity and quality, it is usually described as opaque, transparent, dull, or shiny. A simple way to classify if it's a metallic or non-metallic, like for example, metallic luster is shiny like with silver and gold. Non-metallic luster on the other hand can be described as glossy, pearly, silky, and so on. As you can see, a good example of a mineral with a glassy luster is quartz. The next factor is cleavage. It is the tendency of a mineral to break along certain planes to make smooth surfaces. It represents a direction of weakness in the crystal lattice. Minerals may have cleavage in multiple directions. It may be 1, 2, 3 directions, and so on. However, do note down that some minerals do not have a cleavage. Quartz again is a good example. The next factor is hardness. Surely, it is quite simple to understand by its name. In terms of identification though, it refers to the strength or resistance of a mineral from being scraped or punctured. If we look at the presentation, we will see the Mohs hardness scale. The scale is based on 10 reference minerals, from talc being 1 at the softest and diamond being 10 at the hardest. With this scale, we are able to test the hardness of a mineral. For example, if a mineral can scratch apatite but quartz scratches it, we know that its hardness is between 6 and 7. The last factor is color. Now, color may be useful but it isn't very reliable. This is because some minerals can be very similar in color. A good example is gold and pyrite. Pyrite is commonly referred to as fool's gold because it looks a lot like it. Also, some minerals may come in varying colors. Again, like quartz, though usually clear, it comes in a variety of colors like pink, gray, and even brown. As Erliana had stated a while ago, minerals' physical properties are caused by the particular orders of atoms. Thus, the variation of quantity of some elements may change and affect their colors. Let us now move on to rocks. I'm sure we all know what rocks are when we see them. But what actually are rocks? As mentioned, rocks are composed of one or more minerals combined. They are a natural, solid matter, stone, or mineral mixture. So we all know that rocks are basically everywhere, right? This is because they are formed the Earth's solid outer layer, the crust, and most of its interior with the exception of the liquid outer core. Rocks are more often classified into 3 different types. But before we get into them, we must first understand the rock cycle. Starting off, when magma comes out of the mantle through volcanic eruption, cools down and solidifies, what are formed are what we call igneous rocks. These are primary rocks because they are formed directly from the magma. Through time, various weathering agents or exogenic forces act upon this rock, breaking them into small pieces of which we call sediments. So these sediments are buried under several layers, compacting and cementing together through time and pressure, eventually forming sedimentary rocks. Now, all rock can be heated. Heat comes from inside the earth due to pressure, and it also comes from friction when tectonic plates move. And we can say that heat bakes the rock, causing it to change and transform. And because these rocks change, what they form in the end are called metamorphic rocks. Through weathering and exogenic forces, these metamorphic rocks can be broken down into sediments, thus forming sedimentary rocks again. Metamorphic and igneous rocks ultimately find their way into the mantle through subduction and melt into molten rocks or magma. As the magma comes out and cools again to form igneous rocks, the cycle starts over again.
Now that we had a quick overview of the types of rock, it's time for us to dig a little deeper. The first type of rock is called igneous rocks. These are called primary rocks and are formed when lava cools down and solidifies. And there are two types of igneous rocks, intrusive and extrusive. When magma fails to come out, ultimately settling beneath the surface, intrusive or plutonic rocks are formed. They crystallize below the surface, and the slow cooling allows large crystals to form. So our examples are granite, gabbro, and diorite. Now when volcanoes erupt and lava cools down on the Earth's surface, extrusive or volcanic rocks are formed. They cool quickly, which allow small crystals to form. Some examples are basalt, pumice, and obsidian. Igneous rocks may be classified according to texture, mineralogy, chemical composition, geometry, and mode of occurrence. However, they are most often classified according to texture. Texture, in terms of rocks, refers to the rock's general appearance based on their size and arrangement of its crystal components. There are several different textures, but we will just briefly touch up on the four most common ones. First, we have coarse-grained or phaneritic igneous rocks. These rocks are intrusive as they came from beneath the Earth's surface and consist of large crystals. Second, we have fine-grained or aphanitic igneous rocks. These rocks, on the other hand, are extrusive. They rapidly cool on the surface of the Earth, resulting in small, fine crystals. Sometimes they cool so fast they don't develop crystals at all. Third are porphyritic igneous rocks. It consists of large crystals embedded on a group of small crystals. This is usually due to a multi-stage cooling history. They may have cooled slowly while beneath the surface and cooled quicker when they rose to a shallower depth. And lastly are glassy igneous rocks. These are formed when they cool so quickly, crystals have no time to form.
Now, let's move on to sedimentary rocks. Sedimentary rocks form when sediments or broken down rocks compact and cement together through time. These rocks considered secondary. They form from igneous rocks, which are primary rocks. These are also the most commonly seen on Earth's surface. There are three types of sedimentary rock: clastic, chemical, and organic. Let's quickly run through all of them. First is clastic, which are also the most common type of sedimentary rock. These are formed from sediments or pre-existing rocks, aka clasts that were broken from weathering processes. Then, they are transported by erosion through streams, wind, and glaciers. Ultimately, when the transportation agents lose energy, as sediments continue to build up, they first compact together, then cement. Next, we have chemical sedimentary rocks. These are formed by precipitation of minerals from water. This is when dissolved materials come out of the water. To precipitate water, instead of evaporating the water, you may change its temperature or acidity. Like for example, limestones form in oceans which do not evaporate. So when seawater heats up and cannot hold as much as calcite, calcite is precipitated out of water, forming limestone. And lastly, we have organic sedimentary rock. These form from accumulation and lithification of organic materials or debris like leaves, plankton, and other plants and animal material. We are now so close to the end of our discussion as we discuss the last type of rocks, which are metamorphic rocks. Metamorphic Metamorphic rocks are formed when rocks transform and change due to heat and pressure through time. There are certain conditions that must be met to form these. The rock must be exposed to high heat, pressured or to a hot, mineral-rich fluid. And these conditions usually found. There are two basic types of metamorphic rocks, foliated and non-foliated. Foliated rocks have layered or so-called banded appearance, which is produced by exposure of the minerals of the heat and pressure. Last but not the least, we have non-foliated rocks, which are simply those do not have layered or non-banded appearance like marbles and skarn.
And that about wraps it up. So we hope you guys understood what we've discussed today about rocks and minerals. We hope to see you next time. Bye!